I've already done 2 graph chart derivative problems for you, so here's the third one that I'm going to give you. And this is page 3. But this is from 2016, so there was one in 2019, there wasn't in 2018, but 2017 and 16, and you can see the rest of the packet to see what years they actually gave this type of problem. But there's this big fancy chart. It has all kinds of the value, derivative, so it looks like we have F and G here. Okay? And on this one, I'm not doing it for you. I'm going to just give you some hints along the way and let you struggle, succeed, and check answers, right? I did provide a link on my website so you could easily see if you're doing problems correctly or not, okay? All right, so let's start it, give you some hints, and then you'll go ahead and try it. So the function of f and g have continuous second derivatives, right? So once again, now we can, well, first of all, we could use these values, and also we can assume things along the way using theorems like the intermediate value theorem, mean value theorem, okay? The table above gives you values of the function and their derivatives at select x values. So nothing all that interesting. Other than, of course, they give us a new k value, right? And the question actually asks us to write the equation for the line tangent to the graph of k at x equals 3. So what's the question? Write the equation of a line, which means we need a point and we need a slope, right? A point and a slope. So we're going to get the point by just plugging in x is 3 in this spot. So we're going to have f of g of 3, and you're going to use your chart to figure out what g of 3 is first, and then go ahead and plug that value into f, and that's going to get you your 3 comma your point. And the next thing you're going to do is take the derivative of this, which is going to be k prime equals the derivative of f with g written in it times, right, where we have the derivative of this thing and then the derivative of that thing. That'll help you get your slope. And then y equals mx plus b, because I like slope-intercept form more, but you could use point-slope form if you wanted. You have your x, your y, your m, and then you're going to go ahead and find your b value, okay? And your final answer should look in this form, or in point-slope form if you wanted that. All right, so next one. New function, h of x, and they want us to plug in 1 into the derivative, which means pretty much just quotient rule, right? So be really careful on this. This seems like it should be pretty easy points. Derivative of g with f written minus the derivative of f with g written. And then square the bottom and away you go, whatever that means, okay? And you're gonna use this chart up above to go ahead and plug in 1, so you should be living in this column right here, sorry, this row right here. And there's the value of f of 1 and then f prime of 1, and using all those values to figure out those spots right there. But plug in, actually write down g prime or write down f prime, where those pieces go, okay? And be really careful. Last part is, it's a little tricky because they want us to integrate from 1 to 3, and they want us to integrate the second derivative. But it's not just the second derivative, because the integral of the second derivative would just be f prime. Right, we would get f prime if we integrated the second derivative. But they have this 2x in here, which makes me kind of feel like it would be a u substitution type problem, dx, and then the derivative of u du equals 2 dx. There is no 2 that's matching in the problem out in front, so we would move it to the other side, and I feel like there would be a 1/2 in the problem in the long run, right? And we would still have our 2x. We would still have to plug in from x is 1 to 3. But go ahead and try it. Think about it a little bit. But the idea behind it is a u substitution problem. And now we have to plug in 3 and 1 and then take half of the final answer, or take half along the way. Okay? Like I said, you can check your answers on my website. There's a link where it says AP for your response questions. So good luck.